Hi, we are going to present the real-life examples of dynamic structure. My name is Anshana Adlina and I'm going to explain the introduction of dynamic. Dynamic is the study of forces and their influence on the motion of objects. Dynamics can be divided into kinematics and kinetics. Kinematics describes the motion of an object in terms of its displacement, velocity, and acceleration, while kinetics is the study of forces that cause a motion of an object. The principle of dynamics is very important in engineering. This is because we need to take into consideration of the motion of the objects such as motors, airplane, and machines. As we know, kinematics is categorized by the object's position, velocity, and acceleration. Position is a vector quantity which have both magnitude and direction. The magnitude S is measured from a origin point O. Displacement of an object is the change of its position, and it can be defined in this equation. Velocity is the rate of change of object's position that can be defined as this, and acceleration is the rate of change of object's acceleration that can be defined as this. Next, as we know, kinetic is the study of forces that cause the motion of an object. According to the Newton's second law, an object accelerates according to the direction of force. So this is the equation. In our daily life, we are surrounded with a lot of dynamic structure and movement. For example, when the paper airplane fall, when we play tennis, play basketball, and water slide in the water park. So, playground swing is one of the example of dynamic in our real life. The swing works by changing potential energy into kinetic energy and back to potential energy again, and it will repeat it all over again. When the potential energy is maximum, then the kinetic energy will be zero and vice versa. The higher the swing is, the potential energy will be higher. The objective of this case study is to understand the dynamics problem for moving playground swings. Next, we also study the potential energy and the kinetic energy for the swings. All forces, including the tension force acting on the swings and the acceleration, will be measured and calculated.
Hi friends! So today, I would like to demonstrate to you one simple example in our daily life which implement 3 LOs in dynamic, which we are learning in this semester. So come on, I will show you one of them. So yes, we finally arrived. This is the playground. And that will be our subject.
Hi, my name is Shri Mohan, mention number KIB1006 So today I'm going to explain the problem related to dynamics and also the solution for the problem. In our case, Athira has a mass of 50 kg and a center of mass at G. If she is swinging to a maximum height defined by theta equals to 30, determine the tension developed in the cable and also the force exerted in each of the 4 posts, and also determine the normal and tangential components of the swing. Then calculate the angular velocity. So firstly, let's calculate the maximum tension developed in the cable when theta equals to 30. So this is our free body diagram. T acts upwards while W, which is weight, acts downwards. Here, we use the formula of T1 plus V1 equals to T2 plus V2, in which T is kinetic energy and V is potential energy. Now we need to find V2, which is V final, in order to find T. By taking initial velocity equals to 0, so we get this equation by substituting the values in T and V. We fixed our datum at A, so the value of V should be negative Wy. So here V1, we took it as negative 3 cos 30, and V2, 50 times 9.81 negative 3. Then by solving the equation, we get V2 equals to 2.81 meter per second. By using F equals to MAN, we can know that T minus W, it's minus W because with X downwards, so equals to M50, AN equals to V square or radius of curvature, which is 3. So if we solve the equation, we can get the tension equals to 622.10 N. Okay, now let's calculate the velocity when the swing reaches point B. It's here. So we use the formula of T2 plus V2 equals to T3 plus V3, which is 2 is here and 3 is here. By taking V2 equals to 2.81 meter per second, which we got the answer from the previous problem, we substitute V2 equals to 2.81 and V3, which is the velocity we want to find now. So by solving the equation, we can get V3 equals to 0. So when the swing reaches point B, it becomes 0. So when it starts, it's 0. Here it reaches the velocity of 2.81 meter per second, and when it reaches B, it becomes 0 again. Now let's calculate the force developed on each of the posts. In total, we have 4 posts. This side, this 2F represent 2 posts, and this 2F represents another 2 posts. Here, we also have T acting upwards, so it's plus. Then the F is acting downward, so this is negative. We solve one of the side and then we multiply it by 2. So it's negative 2F cos 30, because we want to find F acting in y-axis, so it's cos 30 plus T equals to 0, because summation of Fy is equals to 0. By solving the equation, we can get the value of F equals to 179.58 Newton. For the angular velocity, the equations are quite similar to the rectilinear motion of a particle. So we choose the third equation. Here we have initial theta equals to 0, theta is equals to 60. So when we convert it into radian, because the theta is in radian, we get pi over 3. Our constant acceleration is 9.81 and this is 0. So when we solve the equation, we get angular velocity is equals to 4.53 radian per second. Now let's move to the final part, which is calculate the normal and tangential components. So this is our free body diagram and kinetic diagram. For normal component, we use the formula V squared over radius of curvature, which is 2.81 square over 3, we get 2.63 meter per second. But for tangential components, we need to use this formula, which is Fx equals to MAT. Since AT is acting in x direction, we use T, the tension, cos 6T equals to M50 and AT. Tension is 622.10 we got from the previous problem. So 622.10 cos 60 over 50. We get AT equals to 6.22 meter per second. Now we can find the acceleration equals to 8 square root of AT square plus AN square. we get acceleration equals to 6.75 meter per second square.
Hi and good day, I am Priyanka Pupadi, metric number KIB1006 I am going to explain about the dynamics involved in the swing set. The operation of swing involves kinetic energy and the potential energy. The kinetic energy is the energy from the moving object, while the potential energy is the stored energy from lifting an object against the force of gravity. The gravitational potential energy datum was set at this axis. At this point, the kinetic energy is zero and the potential energy is maximum. As the swing goes to the center of the supporting post, it gains the kinetic energy because it is getting fast and the velocity increases. At the same time, the potential energy of the swing decreases. When the swing is at the center of the supporting post, there is no force uplifted by the gravity. Therefore, the gravitational potential energy becomes zero. At this point, the kinetic energy is maximum. Therefore, the swing has the maximum velocity at this point. As the swing goes upward, the velocity decreases causes the kinetic energy to decreases too. As there is an increase in the height of the swing, the potential energy also increases. At this highest point, the potential energy of the swing becomes maximum. The velocity of the swing is zero at this instant because the swing stops first before it changes its direction. The relationship between the potential energy and the kinetic energy in the swing set is also known as the principle of conservation of energy. Besides, it is also observed when the angle between the swing and the center of the supporting post decreases, the velocity of the swing increases. The changes in the velocity of the swing also affect the normal acceleration and the tangential acceleration, as both of these involve the velocity vector. The tangential acceleration represents the time rate of change in the magnitude of the velocity, which is in the same direction of the velocity, while the normal acceleration represents the time rate change in the direction of the velocity vector, which always directed to the center of the curvature of curve. Therefore, the tangential force at the maximum height changes its direction as the velocity changes its direction, while the tension of the chains in the swing always directed to the center of the supporting poles. The tension of the chains of the swing always opposes the tangential force of the swing. Therefore, when the tangential force changes its direction at the maximum height, the swing goes to the maximum height that opposes the tension. At this instant, the tangential force changes its direction again. Thus, the swing goes to the maximum height of the opposite direction so that the tension is opposite to the tangential force. Based on the question, the force in the supporting post can be determined by drawing the free body diagram. The total tension in both chains is equal to the tension calculated. The force in the supporting post is determined by applying the total force in the y direction is equal to the zero. Therefore, the calculated value of the force developed in each post is 179.58 Newton. As the conclusion, the swing set is the most common real-life case which involves many aspects in dynamics. That's all from us. Thank you for watching the video.